Chapter 7, Section 5. I should have said that for all these other people who weren't here and are listening, that 7.5 is our last section we cover. Review before break, have break, review after break. Isn't this exciting to hear twice? And then we have a test after that. Now the people who weren't here can hear the same thing you did. All right, let's see what we have in Section 5. Similar triangles, we already know that corresponding sides are proportional. And what we see in this section of theorems is if I have special segments like altitudes and angle bisectors and medians, they also are proportional. Now let's review what those three things are. Altitudes. Do you remember what an altitude is in a triangle? It goes from a vertex and hits perpendicular 90 degrees to the opposite side. That's an altitude. So if I know I have two similar triangles, this theorem says those altitudes are proportional with the corresponding sides. They're in the same ratio. Angle bisectors. What's an angle bisector? Cuts an angle into two congruent parts. If I have two angle bisectors, now they have to bisect the same angle, and these altitudes have to be the altitude from the corresponding point. So you can't just pick any two random altitudes. They have to be corresponding ones. Same thing with the medians. They're going to be proportional to the sides. Same scale factor. And the third thing, medians. What's a median? Goes from a vertex to the midpoint of the opposite side. That is a median. And if you have two corresponding medians, they also are proportional to the sides. So the same scale factor again. So we just added three segments that are in the same ratio as the corresponding sides are in similar triangles. So they want us to find the value of x. Now I can't find the value of x unless I first know these two triangles are what? Similar to each other. Now, if I heard somebody say congruent, if they were congruent, I could as well. But these aren't the same size, so if they are similar. So can you tell me, do I know these two triangles, the KML, the big one, and the YZX, or maybe another order, are those similar? What reason? Angle, 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 angle. K and L match up, X and Z. So these are similar by angle, angle. So now that we know they are similar, we know that those, what's the name for this segment? Altitude. I know these corresponding altitudes. And notice it's an altitude from corresponding angles. They match up. The K goes with the X, the L goes with the Z, and the M would go with the Y. So they are the corresponding altitudes. So if I said 16 to X, it would have to be the same ratio as... Now conveniently, they only gave us one other value, but you want to make sure that you match corresponding parts. And we're coming from the one angle mark, and over here we're coming from the one angle mark. So they should match up, 20 to 15. And then it's just cross products like we've been doing for quite a bit of this chapter. You have your calculators or maybe your brains running, whichever works better this time of the day. I don't know. X equals, what do we get? 12? And participate. That's what keeps you awake. If you just sit there and start staring, then you start tuning out, falling asleep, and we don't want that to happen. All right, over here, we want to make sure, do I have two similar triangles in part B? And if so, what reason? You have to look real close. It's maybe a little hard to see from where you're sitting. It's angle, angle again. Can you see that tiny little mark right over there? I kind of hit it. It was over there. It's angle, angle again. So these two things are similar. So what is this line that they are calling 13.5? A median. It is a median hitting the midpoint. And this one right over here is a median. Is it the corresponding median? Is it coming from the same angle? Yeah, so we're good. So if I said 13.5 to 9, 13.5 to 9, can I set up another ratio with something? X, lost my X for a minute. There it is. X corresponds to 3. Now, wait a minute. That's the same position as that X is. How can I say it corresponds to 3? Because they're congruent. You got it. But make sure you understand that's the reason why I can do that. These are both congruent. These are both congruent. So really, from the theorem, this whole side, which is 2x, corresponds to 2 times 3. But we can just drop the twice as much part and say, oh, well, x is correspond to 3. X times 9, or 9x, 13.5 times 3. We can then divide by our 9 to isolate our x. 4.5. Your goal is to be faster than whoever said it before you. All right, let's try this one. We're going to use something called parallax. Does your book use that word? Oh, when you take physics, you'll learn that word. It's called parallax. Liliana holds her arm straight out in front of her with her elbow straight and her thumb pointed out, up. So here she is, just like this. Closing one eye, she aligns one edge of her thumb with a car she is sighting. So here's her detached eyeballs. She's standing right over here. Here is her thumb right over here. And there's a whole bunch of cars lined up. I shouldn't say there's a whole bunch of cars lined up. She is looking over here at a car. Closing one eye, she aligns her thumb with the car she is sighting. So here's what I'm going to do. I have this nice periodic table of the elements chart right back there. So if I hold my thumb up and I close one eye and then I move my thumb so that it is right on one edge. So I line it up right on one edge. It's right over there. Now, when I close the other eye, my thumb just jumped. Stick your thumb out. Focus on something up here. Line it up. I don't know, the edge of the board. Now, you're going to have to move it. Close one eye, and if you need to, close one eye this way. How it is. Hold your thumb up, and then close the other eye and watch your thumb jump. Now, if your thumb jumps over here outside of the board, then switch the sides of the board. Put your thumb over here instead so that when you switch eyes, it jumps this way. You want it to be jumping in the direction of, we can use this idea to measure a width of something. Let me keep reading. You can put your thumb down, or you can keep it up there, whatever you like. Next, she switches eyes without moving her head or her arm. Thumb stays in the same spot. She just switched eyes. The car appears to jump 4 car widths. So you can say, well, I was telling you your thumb jumped. I guess you can say, oh, the thing you're looking at jumps. Just a matter of perspective. Mine appeared to jump about 3/4. Well, thank you. Yeah, mine jumped about 3/4. All right, 3/4 of the width of what I was looking at. If Liliana's arm is about 10 times longer than the distance between her eyes, you're going to be able to do this in the future. First, you're going to have to, and you think it looks funny, just do it when you're alone in your room sometime. Take your ruler, and you've got to go to the mirror, and you've got to measure. You have to look in the mirror. You have to measure how far it is between your eyeballs. You have to know that. And then you have to know, well, how long is it between my eyeball to my thumb? So, like I say, if you're too worried that somebody thinks you're funny, then just do it when nobody's in your room. 10 times longer than the distance between her eyes. So here they have, this is 10 to 1 is what they are saying. That's the ratio. Length of her arm out there to between her eyeballs, 10 to 1. The car is about 5.5 feet wide. So Liliana happens to be somebody who is aware of the world around her, and she knows, oh, car's about 5.5 feet wide. Estimate the distance from Liliana's thumb to the car. So the question becomes, how far away are you from that object that you just saw move? So if this is 5.5 and it went 4 of them, then you help me out. $22. 5.5 times 4. 22. So this becomes 22, and I have just created two similar triangles. These are going to be similar because unless you're standing like this, one eye is closer than the other, you need to square up with it. Then it's the same distance on both sides. So I've got this nice isosceles triangle going on right over here. And it's going to be similar to this one right over there. And these two things are just altitudes that I'm comparing. So I can say, oh, 10 to 1. Let me do it that way. And you can do it many ways. How would that match? X to 22. X to 22. So x times 1, or x, equals 10 times 22. What's 10 times 22? That's how far away she is from something. It's kind of a cool estimation tool. Like I say, you've got to know the ratio there. So just measure it sometime, and then you'll know that number, whatever that number is for you. And then you can do that. It's like, oh, I know about how far away that is right over there. Moving on to other exciting things in geometry. Triangle angle bisector theorem. If we have a triangle, this is the original triangle they're talking about. And then if we have an angle bisector, so there's an angle bisector right there. So I know these two things are congruent. Then that angle bisector has divided up this side of the triangle. Notice that angle bisector just chopped off two pieces right over there. This is Km, so that I can use the same letters they did, and this is ML. Those two segments are in the same ratio as these original sides of the triangle that weren't part of that angle bisector thing. These two right over here. Km to Lm, Km to Lm, here to here, is going to be the same ratio as Kj to Lj. Notice they went top to bottom on these segments. I need to go top to bottom on these sides of the triangle, or the same order. Just like when we set up any other proportion, I need to be moving in the same order. So the triangle angle bisector theorem says there's one more proportional relationship. So let's try it out down here, a proportional relationship. Since RT is an angle bisector of triangle QRS, you can use the triangle angle bisector theorem to write a proportion. I know, now I'm going to start with the two sides. 6 to 14 must equal x to this. What would I call that? Perfect. 18 minus x. You guys have had to do that from time to time. There it is. So if I do my cross product, 6 times 18 minus x would have to equal 14 times x. What's 6 times 18? More precisely than a big number. How much? 108 minus 6x equals 14x. I'm going to move up here. If I add 6x to 14x, what's that? 20x. And I still have my 108 on that left side, so now you can divide by 20. 5.4? X must be 5.4. And we could figure out the other part if we wanted it as well. Same idea right down here. I'm going to start with x. Notice we have an angle bisector right there. X, put it with something. X to 4. If I go x to 4, it would be proportional with 13 to 6. If I went from the side to this segment, other side to its segment. Works good. X times 6, or 6x, equals 4 times 13. We'll divide by our 6. What's the answer for x? 8.6 repeating, that'd be 8 2/3 then, right? Yes. Let me start with the x on this one. Pick something. X to 14. Now before I go any farther, when I say pick something, x to 14, that works just fine. Or I could have said x to this piece over here. What would I call that piece? 20 minus x. Could I say x to 11? No, that's heading diagonal again. We can't do that. So if we did x to 14, then it must be this piece. What did you call it? 20 minus x to 11. So x times 11, or 11x, must equal 14 times our 20 minus x. So I'm going to distribute that 14. What's 14 times 20? 280 minus 14x. I'm going to add 14x. 25x equals 280. You're going to divide by 25. 11.2? I think I've heard more 11.2s than other numbers that may be floated around. Let's go to your book. We are on page 504. Oh, look back at 501. See that person looking at that lighthouse with holding their thumb up? Don't worry about what people think of you. You say, hey, I'm smart. I know what I'm doing. 504. You're the one that'll know you need to take some water when you go hiking to something that's 5 miles away and they just think it's a half a mile away. Number 1. Find x. Do we have similar triangles in number 1? What reason? Angle, that's kind of a popular one today. What is that x distance called in that first triangle? What kind of length is it? It's a median. All right, so x and that 10 are both medians, so we can pair those things up. X to 10 would match with 12 to 15. Just make sure you keep in the same order. So my next step would be 15 times x would equal 10 times 12, and then we can divide by 15. And again, this is the work I want to see. This is how you got it. How much? 8? Do we agree or not? All right, 8. Number 2. Similar triangles? By angle again. Let's see, x and 9, those are the two, what are those things called? Altitudes. They would correspond with 8 and 6. So 6 times x must be 9 times 8, and we could divide by our 6. 12? A cat that is 10 inches tall forms a retinal image. What's this retina that they are referring to? Back of the eyeball, back of the eye. That happens to be 7 millimeters tall. Now notice something else about that cat in the retina. It's upside down, isn't it? Okay. When you take physics or physical science, you guys studied lenses yet in physical science? Oh, you know all about this. What do we have? A cat that's 10 inches tall forms a retinal image that is 7 millimeters tall. If triangle ABE, the one that goes to the real cat, is similar to triangle DBC, the one that goes to the image, and the distance from the pupil to the retina is 25 millimeters, then how far away from your pupil is the cat? Again, in the eyeball, we have a 7 millimeter height and a 25 millimeter altitude, but I can use those millimeters together, and then I can use the centimeters together, and it's okay because our ratio is the same. So what are my other values? 10 inches? And where does the 10 inches go in my proportion? On top, the height, over x. And this will just be in inches when we are done. 7 times x must equal 25 times 10. Then we could divide by our 7. How tall is the cat? Or how far away is the cat? Sorry, not how tall the cat is. 35.7? And what was it measured in? Inches. Huh, interesting, my book made a mistake. They said 35.7 feet, but that would not be true. It should be 35.7 inches. That's the distance away. So it would have been a big cat if it was 35.7. But number 4. Find the value of each variable. What theorem applies on number 4? Triangle angle bisector is going on. So let's say I started with the x. How do you want to do it? Okay, you can either go to 15 or 4. Either way, I heard 15 first, so we'll go x to 15. Equals 4 to 10. So x times 10, or 10x, would have to equal 15 times the 4, and then we can divide by our 10. Six. Z over 15, you can start that way. There you go. So that missing piece would be 32 minus Z over 9. Z times 9, or 9Z, would equal 15 times our 32 minus Z, doing our cross products. So if we distribute, what's 15 times 32? I'm sorry, say it again. 480 minus 15Z. Next. Add 15Z, so how many Z's? 24Z equals 480. Z equals, is it 20? 20. Boy, that wasn't very hard for theorems today, was it? Page 504. Numbers 1 through 24. Now, I wouldn't mind. In fact, I would like you to have a seat. Thank you. I'm not quite done. I haven't received any, and that's okay. Sunlight, shadow, height of bell tower. That's all right if you forgot about it. But if you want any extra credit, that needs to come in by Monday. That's our last geometry class before break. So hopefully the sun shines between now and then at some point. All right. I'm done. You can start working.